Good morning, student. Today we will go to the next step, that is about the application of derivative. Last time I have explained about the increasing or decreasing function. How can we define the function is increasing? How can we define the function is increasing, strictly increasing or strictly decreasing? And how can we find out the intervals of the function for the given real function? Now we will go to the next step, that is another way of application of derivatives. We are going through the different kinds of derivative one by one. First this 6.1, that is rate of change, and the second one is the increasing or decreasing function. Now come to the third one, that is called the tangent and normal. Equation of tangent and normal, lesson number 6, and the 6.3 exercise will also based on this one, 6.3. okay, that is the based on equation of tangent and normal. So before going through the equation of tangent and normal, first we have to discuss more about the basic, what are the basic behind the equation of tangent and normal. Some part of coordinate geometry we have to need. First, that the equation of a tangent, because tangent is a straight line. So what is the equation of a straight line? What is the way to express the equation of a straight line? Because tangent and normal also a straight line. So what is the tangent? Suppose that this is the axis, x and y axis, and this is the curve, this any curve. Okay. Suppose that there is the curve that defined by y equal to f of x, that is the curve, and this is the point where we have to find out the tangent. So that is the point is x1 y1, okay, x1 and y1, that is the point, and we have to draw such a line which touch the graph or curve at the particular point, that is called tangent of the given curve, this one. Okay, this is the point P. Point P is the given point, and we have to find out the equation of tangent and we have to draw the tangent. At point P, we touches the line, this one, y equal to fx, that is the equation of a line P, point P here. This is the point of contact where we draw the line, this one, tangent, y equal to fx is the curve, that is the equation of the curve, and we have to find out the equation of tangent. What is the tangent? Tangent is a line which touches the given curve at a given point, that is called the tangent. A straight line which passing and which touching the curve at a given point, that is called the tangent. You can observe that that is also a straight line. So means if you know that about the equation of line, straight line, then we can easily represent the equation of tangent of a curve at a given point. Suppose that you have given the point x1 y1. If we remove this one, all of this thing, what can we say about that? That is called the, suppose that this is the line, that is the point x1 y1 p, equation of a line passing through a given point with slope m, that is called the slope. M equal to also a tan theta, you know that is theta, and the x-axis. What is the slope? Slope is the measure of the angle with positive direction of the x-axis to the anti-clockwise direction. You can see positive x-axis and the measurement of this one, that is called the slope of the straight line. So what the equation of a straight line? Equation of a straight line, equation of a straight line given by y minus y1, suppose that, straight line passing through a point P x1 comma y1 and having slope m What is the equation of a line that passing through a given point P and slope m with positive direction of x-axis? that is given by y minus y1 equal to m into x minus x1. That is the equation of a straight line. That is called the slope of a line with positive x-axis in anti-clockwise direction. Okay. If you are given the 2 points, how can we find that equation of a line passing through 2 points? Equation of straight line with 2 points. So how can we find y minus y1 equal to y2 minus y1 upon x2 minus x1 bracket में in bracket x minus x1. 2 points. What are the 2 points? x1 comma y1 and x2 comma y2. Okay. So this is the equation of a line with passing through a one given point. That is the one first. That is the equation of a line with passing through 2 given points. If there is, in place of slope, we have given the 2 points. So we can decide with this equation, which if we given the 2 points, then we have to use this one. If we given 1 point and slope, then we can use this one. Okay. Now how can we find the slope of the tangent? What is the tangent? How can we use this type of equation of line for finding the equation of tangent and normal? A line. This is the given curve. Suppose that this curve is given you, and that is the point. We have to find out the x0, x0 and y0. Okay, that is the P point, and curve is given you y equal to f of x, and the tangent we have to draw this one. Okay, and we have to find out the equation of tangent. What is the tangent? Tangent is a straight line which touches the given curve at a given point. That is called tangent. Okay, so how can we represent the equation of a tangent? For equation of a tangent, first we find out that equation of a straight line, we have to need 2 things. First one is the slope, second one is the point. Point you have given x0, y0, but we need the slope. What is the slope in derivative form? How can we find the slope of the given function? Suppose that you given the function y equal to 4ax, 4ax square, y equal to, or y equal to 3x cube. So in such a way, how can we find the slope in this way? That is not possible for the coordinate geometry, but we can find with the help of derivative. So what is the slope? Slope is another form. What is the slope? Slope is the derivative of a function of a curve. Curve, you can say function. Curve is also a function here. Curve y equal to fx is called slope of tangent. Okay, slope of tangent is the derivative of a curve or function y equal to fx. You can get this, see there, y equal to fx is a curve may be this one 4x square, 3x cube, different kinds of curve may be here, but we have to find out the derivative of this one, and the derivative is called the slope of the function. So another way we can say m equal to, if y equal to slope of function of curve y equal to f of x. So what is the slope of this one? Derivative. It means f dash x at a given point. Derivative of a curve, it's called the slope of a tangent at a given point. At a given point, what the point given you, x0 or y0, sometime maybe x1 y1 also, sometime we can use x1 y1 in place of x0 y0, or another different kinds of variables we can use in place of this one point. Okay, parametric, we can use the parametric coordinate of the point. So what is the derivative of this one, f dash x, or either you can say dy by dx, what we can say, dy by dx or f dash x. Dy by dx at the point x equal to, that is given name, x0 or y0 comma. So here we can use x0 also. Dy by dx means derivative of first derivative at the given point. What the point is given, x0, x0 or y0. So at the first you find out the derivative, then put the value in place of x, x0, what place of the point, what are we given, that is called the slope of. The slope of the curve we can find with the help of first derivative at a given point. At a given point may be here. Suppose that you are given the y equal to 3x cube, and you have to find out the slope at x equal to 2. Okay, suppose that x equal to maybe 2 here. So what the slope of this one? The slope of this curve. Example, we can use this example. Suppose that y equal to given you 3x cube, or either you can say f of x is a curve. F of x given you 3x cube, and we have to find out the slope. What the slope? Derivative of a curve or function is called the slope of tangent at a given point. At a given point. So f dash x, what the f dash x? F dash x at the point, what the point at, find the slope. If fx equal to x cube, then find the slope at x equal to 2. At x equal to 2. So first derivative f dash x, at which point we have to find x equal to 2. X equal to 2, or sometime we can use as this one as a some, in some books we can use this one. Okay, in this way. Or either you can say in place of y you can use this one. Suppose that y is the function, and then we have to find out the derivative dy by dx in this way. At x equal to which point? At x equal to 2. So first we have to derivative this one, 9x square, and put the value x equal to 2. 9 into, in place of x we have to put the 2 square. You can say that 4 9 are 36. That is the slope of the given curve. Okay, that is the another way to find out the slope. In coordinate geometry we use the m equal to tan theta, that is also a step. So slope representation may be 3 types. Slope. So what is the slope representation? Slope of y equal to f of x at x0 and y0 will be dy by dx. Okay, dy by dx at the point x0 and y0 is given by f dash x0. Okay, this one. First you find out the first derivative, then put the value in place of x variable, whatever x0, put the value of xy. So in this way we can find the slope. That is called the slope of given tangent. Slope of tangent to the given curve. To the given curve y equal to f of x. That's called the f of x. Okay, that is the equation of tangent. How can we find? So equation of, now that is the slope. Now we come to the equation of a tangent. How can we find? We find out that is the slope of the tangent. Either you can represent this one or this one. That is called the slope of tangent to the given curve at the point x naught and y naught, p, at the point p. So now equation of tangent. Equation of tangent, you can observe that this is the straight line passing through a one given point having slope this one. This is also a straight line. So tangent is also a straight line. So we can use the equation of a straight line, particular equation of a straight line with having the slope and one given point. So that is called the equation of tangent. So what the equation of a straight line passing through one point? Suppose that equation of tangent passing x naught y naught and slope. What the slope? And slope f dash x0. You can see that is the slope of tangent. So what the equation? Y minus y1, in place of y1 you can use y0, y0 equal to, what can we write? Slope. What is the slope? F dash x0 in bracket x minus x0. That is the equation of tangent. Okay, that is called the equation of tangent. Suppose that the slope, that is the f dash x is the slope and that is the point y0 and x0. So equation of a tangent passing through this point and having slope this one. So that is also a representation of a equation of tangent. Suppose that they are given that equation of tangent in this way. If the equation of tangent is parallel, that is the curve. Okay, the tangent is this one at this point P. Okay, you can see that is the tangent is parallel to the x-axis. What the angle between the x-axis and the straight line? This one tangent 0. Tan 0 means 0. Slope will be 0. So in other words, we can say that if the tangent is parallel to the x-axis, then the slope will be, if tangent is parallel to x-axis, then m equal to, or you can see dy by dx, or f dash x also equal to 0. There is no angle between this one. So what is that? Know that if parallel line and what the slope m equal to tan 0, there is no angle between the x-axis and the straight line. Tan 0 means 0. Hence slope of this one divided, that is also a slope representation, that is also a slope of representation, that will be 0 for that one. If the slope was, you can say, if the tangent is parallel to x-axis, if the tangent is parallel to y-axis, so what can we say? Suppose that if we draw this one in this way, that is the parallel to y-axis, that is the y-axis, and that is the x-axis, and tangent at the point P of this curve. Then the equation of or slope of this tangent, what we slope, you can see that is the perpendicular 90 degree, hence m equal to what will, m equal to tan 90, or you can say infinity, so not define, no? If tangent is parallel to the axis, then slope m equal to infinity, or another way you can say 1 by 0 you can use. So that is the representation of this one. Then slope of m will be not defined for the parallel with y-axis. Okay, now of the equation. What is it? This is all about the equation of tangent. And now come to the equation of normal. What is the normal? The line which is perpendicular at the point of contact with tangent, that is called the normal. A line, a perpendicular line, a perpendicular line with tangent at a contact point to the curve is called normal of the given curve. Okay, suppose that this is the given curve, that is the curve is given you, and that is the tangent at the point P, that is the point P. Okay, now we have to find out the normal. So what is a perpendicular line with tangent? Perpendicular may be here, this one also perpendicular, but where? At a contact point. We have to draw the perpendicular line which is perpendicular at the contact point P. So that is this one, 90 degree. This line is called the equation of a normal. That is called the normal to the curve. So you can see that there is equation of this line and this line will be same, but only a small difference, that is the slope. Only what is the difference between these two? Slope. If we suppose that is m1 and that is the slope of m2, if the slope of this line will be m2 and this line is m1, you know that the condition for the two perpendicular line with slope m1 m2 is equal to product of slope will be -1. In other words, we can say that m2 equal to -1 upon m1. Okay, that m2 is the slope. If you know that the slope of tangent, then you can find out the slope of normal with the help of slope of tangent. Okay, in this way we can find out the slope of normal, and we can find out the equation of normal. Suppose that the equation of tangent I have found out just before. Equation of tangent of curve y fx at x0 y0 is given by y minus y0, that is the dy by dx, or you can say f dash x0 into x minus x1. That is the equation of tangent. Now we have to find out only this one. Now equation of normal, what will be? Equation of normal is given by y minus y0 equal to what the difference? If we the slope of f dash x0, that is m1. Suppose that using this condition, m1 is given you f dash x0. Okay. Now what will be m2? m2 is equal to minus 1 upon m1. It means minus 1 upon f dash x0. F dash x0. So what will be the slope of this one? In place of this one we can write minus 1 upon f dash x0 into x minus x0. What they simplify then? Y minus y naught f dash x0 x0 plus x minus x0 equal to 0. That is the equation of normal. In this way we can find out the equation of normal. So you always remind this one, the slope of the tangent, slope of the normal equal to minus 1 upon, from we can conclude with the help of slope that in this way slope of normal equal to minus 1 upon slope of tangent. Okay, in this way we can find out the slope. If we know that slope of tangent, we can find the slope of normal. If we know the slope of normal, then we can find out the slope of tangent by using this relation. Okay. So this is all about the exercise 6.3. In the base of this one, at the base of this one, you have to do exercise 6.3. Okay, next question. So now come to the exercise. Question number 1. Find the slope of the tangent to the curve y equal to 3x raised to the power 4. 3x raised to the power 4 minus 4x. This is the curve and you have to find the slope at x equal to 4. At x equal to 4, slope you have to find out. How can we find the slope? Y given you slope. What you know that what the slope? Slope means derivative of the curve at a given point. Given point is given you x equal to 4. So first you find out the first derivative dy by dx. Dy by dx at x equal to which point? 4. Find out the dy by dx. 12x cube minus 4. Okay. Dy by dx equal to, put the value of x equal to 4. Cube minus 4. What will come? And simplify this one. In this way we can find the slope of the given function. Okay, 6 4 4 is 16, 16 multiply you can find out by solving this one. Find the slope of the another one, y equal to x minus 1 upon x minus 2. Similarly the third one, whose x coordinate, third one I am giving you. Find the slope of the tangent at the curve y equal to x cube minus x plus 1. X cube minus x plus 1 at x coordinate, with x coordinate given you, x coordinate is given you is 2. Find the slope of the curve, this one whose x coordinate is at the point where x coordinate is 2. So similarly you can find out dy by dx. X coordinate means x equal to 2 and find the derivative of this one, 3x square minus 1 plus 0. So put the value this one, what will it come? 3 into 2 raised to the power square minus 1, that is equal to 11. Okay. That is all about the. Now in this exercise all are easy question. So you can do in this way. Find the slope of the normal. Question number 5. We come on the question number. Find the slope of normal. Now we have to find out the normal. How can you find the normal? Slope of normal to the curve. To the curve. Which one? X equal to a cos cube theta, a cos cube theta, and y equal to a sin cube theta at theta equal to pi by 4. At theta equal to pi by 4. So you know that first we find out the slope of tangent, then you can find out the slope of normal. So first what can we write? Slope of normal, tangent. Slope of tangent at theta equal to pi by 4, that is given by dy by, what that means, I dy by dx at theta equal to pi by 4. We need this one for this one. So first we add the dy by dx. How can we find? First we find out the dy by dx. dy by dx means dy by d theta with respect to theta. Both are common variable theta, so we have to differentiate both variable with respect to theta. dy by d theta and dx by d theta. We can find what was the dy by d theta. You can see 3a sin square theta cos theta, and similarly for the dx by d theta 3a cos square theta into minus sin theta. This one will cancel out, and that is also will be cut, and this will also be dismissed here. So what will is in minus sin theta upon cos theta. You can say minus tan theta. That is the slope. Now we have to find the slope of normal. You know that slope of normal equal to minus 1 upon slope of tangent So how can we write? Minus 1 upon slope of tangent is a tan theta. 1 upon tan theta, that is the slope of tangent. Now slope of normal at theta equal to pi by 4 is given by one upon tan pi by 4, that is equal to 1. Okay. So in this way we can find the slope of tangent or slope of normal.